Okay. Good afternoon. Good afternoon. So today, after the celebrations of Vinayak Chavithi, so we came to the next session, that is lecture 3 in the unit 1. Lecture 3 in the unit 1 in the fluid mechanics subject. So in the fluid mechanics, we have discussed some topics. What are the basic introduction of fluids? Okay, what is the definition of fluids? Okay, how we are using the fluid mechanics. So here in this class, we will discuss about the fundamentals of fluid mechanics. What are the applications of fluid mechanics? What are the units, dimensions of the fluids depends upon the application. So we will discuss this in the lecture 3 class. Okay. So I've already discussed in the last class what is the fluid mechanics. So it's a science which deals with the motion or stationary water bodies under the influence of forces. So ఎప్పుడైతే forces physical గా యాక్ట్ చేస్తున్నాయో స్టేషనరీ బాడీ మీద మూవింగ్ బాడీ మీద ఆ కాన్సెప్ట్ ని we are discussing them as fluid mechanics. Statics అంటే ఏంటి? So already discussed. Static means a branch of mechanics that deals with bodies at rest. Bodies means the water body. Whenever the water body is at rest, the concept is called static mechanics. Whenever the body is at motion, the concept is called dynamics, fluid dynamics. ఈ రెండింటిని కలిపి ఏం చెప్తున్నాము? We are discussing this as totally a fluid mechanics concept. Okay, so a fluid mechanics means it is a subject dealing with the behavior of water both in fluid statics as well as in fluid dynamics, and how they are interacting with the fluids, how they are interacting with the solids or other fluids at the boundaries. Boundary and enti? A boundary is a physical system where the water or any liquid or solid or any gas where it will not come outside through a system. A boundary is a outer surface of a layer where the solid, liquid or gases are enclosed. It may be a jar, it may be a glass, or it may be any body like that. Then what is the fluid mechanics, kinematics? It is the study of fluids in motion where pressure forces are not considered. ఎప్పుడైతే pressure forces just holding the object when the fluid is in motion, that is nothing but a fluid mechanics. Whenever the pressure forces are not applied, then we are calling them as fluid kinematics. Fluid kinematics. Next, fluid dynamics. So dynamics and motion logic. So here the study of fluids are in motion, but the pressures are considered on it. So the study of fluids in motion where the pressures are considered on it. Next. Hydrodynamics. Hydrodynamics, the study of motion of fluids that can be approximated in incompressible processes such as liquids, especially water, gas, and low speeds. Hydrodynamics, the study of fluids that can be incompressible such as liquids and gases. Next one, hydraulics. Hydraulics means a subcategory. It's a
Sir, voice not audible, sir.
వాయిస్ వస్తుంది కదా రావట్లేదా? It's okay.
Yes, sir.
Next one is gas dynamics. The gas dynamics deals with the concept of gas which undergo changes through the nozzle at high speeds. So here the gas dynamics gas dynamics basically deals with the flow of fluids that undergo significantly density changes. Density means it's a property of a fluid. Density changes such as the flow of gases through nozzles at very high speed low. Whenever the gas are flowing at a very high speed through a nozzle that deals with the dynamics, gas dynamics. Whenever the density means changes in the volume, volume. Then we can deal with the gas dynamics. That's the gas dynamics. Next, aerodynamics. Aerodynamics means the flow of gases, especially air, over the body, such as vehicles, aircraft, rockets, automobiles, or high or low speeds. So aerodynamics is also a branch of science that deals with the concept of especially air. For example, if you are going in a highway with a high speed, taking any car, if you are taking a lorry, the lorry design is the front design of lorry is flat. So if you see some other cars, rich cars, already good cars, premium cars, the design is an aerodynamic design. Aerodynamic design means so we are passing towards the highway, the air loంచి దూసుకొని వెళ్తున్నాం generally. So whenever we are forcing, whenever we are piercing the air and going very fastly, air అనేది మన క్యాబిన్ మీద నుంచి పైన గ్లాస్ మీద నుంచి flow very freely. Whenever it flows very freely, automatically the speed also increases. The speed also increases. That is nothing but the concept of aerodynamics. Aerodynamics. Next, oceanography, hydrology, meteorology. This deals with the water which are coming naturally occurring flows under them. We are calling them as naturally occurring flows. Next. Next. So whenever a liquid or whenever a gas is in any container, what happens? So if you see the figure here, whenever the liquid is in a container at a certain level, so the liquid is having some free surface on the top of the water. So whenever the gas is in the liquid with open channel, then what happens? The gas will escape from the surface. The gas will escape from the surface. So in a liquid, the groups of molecules can move relative to each other, but the volume remains relatively constant. What happens? In the liquid also we are having some molecules where these are moving and touching the boundaries and moving inside the liquid based upon the level. But it does not reduce the volume because of strong coercive forces between the molecules. So, if the molecules will not disturb the other molecules, thereby it is going outside to the air. So, whenever it is in a boiling condition, whenever the liquid is in a boiling condition, so at a certain temperature for some time, then automatically the liquid will evaporate and converts to the gas. Then there is a changes in the volume. Whenever there is a strong coercive force and we are not heating the fluid, then automatically the liquid is stable. As a result, what happens? The liquid takes the shape of container and it forms the free surface in a larger container in a gravitational field. Okay. So due to the gravity, the liquid is staying at the bottom side with some pressure. Next, to see the gas expands until it encounters the walls of the container and fills the entire available space. Entire available space. Why? Because the gas molecules are widely spaced. See here, the gas molecules are obviously spaced, obviously different from one molecule to the other molecule. Thereby, the coercive forces between them are very small. So in the gas, the cohesive forces are very small when compared to the liquid. Unlike liquids, the gas in the open container cannot form a free surface. So whenever if you see the figure of this one, when compared to this one, here the gas molecules will not settle in a free surface. When it is settled, whenever we are applying any pressure on the gas and we are closing inside the chamber, then automatically we can see the changes in the gas. Right. Next. Next one. So Newton's laws of viscosity. As already you know this Newton's laws of viscosity. Newton's laws of viscosity. So what is the Newton's laws of viscosity? It states that the shear stress tau on the fluid element layer is directly proportional to the rate of shear strain. Therefore, the constant of proportionality is expressed as tau is equals to mu of differential in the du by dy. Okay. which obey above the relation is known as Newton's fluids, which does not obey the relation is known as non-Newton fluids. So whenever this relation obeys, then we are calling this relation as Newtonian relation, or whenever it does not obey the law of Newton's law of viscosity, we are saying it as non-Newtonian fluids. Next, variation of viscosity with temperature. So we'll discuss the concept of variation of viscosity with the temperature. Here, temperature automatically affects the viscosity. What's the meaning of viscosity here? Viscosity means some sort of the property which holds the liquid, which holds the liquid. Means if the viscosity is less, automatically the liquid will open, or the liquid will flow away. When the viscosity is high with some viscous nature, it will hold the volume. Here, the temperature affects the viscosity. The viscosity of fluids decreases within the increase in the temperature. The viscosity of fluids decreases with the increase in the temperature, while the viscosity of gases increase with the increase of temperature. So ఇక్కడ ఏమని జరుగుతుంది ఇక్కడ, whenever you are taking the temperature into the effect with viscosity, the viscosity of liquids decreases whenever we are adding temperature to the liquid. In the same way, whenever the viscosity of gas increases with increasing temperature, so whenever you are increasing the temperature of any liquid, the viscosity of gas also increases. But whenever the viscosity of fluids increase with temperature, the viscosity is decreases. The viscous force in the fluid are due to the cohesive forces and molecular momentum transfer. Next. So the relation between the viscosity and temperature for fluids and gases are. So generally, the for liquids you are having one type of relation with temperature. So for gases we are having one type of relation with the temperature. So if you see for liquids, the mu is equals to mu naught. That implies 1 by 1 plus alpha theta plus beta temperature 2. So whereas mu is equals to viscosity of liquid at temperature twice, whereas mu 0 is equals to viscosity of fluid at 0 degrees. At 0 degrees. Next, at 0 degrees. Next one. Above equation shows the increase in temperature. So if you see the alpha and beta are the constants for the liquid, where the water mu 0 is equals to 1.79 into 10 to the power of 3, where points alpha is equals to this value and beta is equals to that value. So here, automatically for liquids, what happens? When the temperature increases, the viscosity is decreases. Now see for the gases, the mu is equals to mu naught plus alpha t minus beta t square. Here for air, mu naught is equals to, we are given the value, alpha is equals to the value, beta is equals to some value. Here the above equation gives whenever the temperature is increased, the viscosity also increases. So simply keep in mind. So for gases, whenever the temperature is increased, automatically the viscosity of gas also increases. Whenever the temperature is increased, the viscosity of liquid increases based on the formula. Next. Next one, we'll discuss the types of fluids. So we are generally, what are the types of fluids? We'll say viscous fluids, non-viscous fluids. But this is general category. But the actual technical category of fluids are classified into various types. First one is a ideal fluid. Second one is real fluid. Third one is a Newtonian fluid. Next one is non-Newtonian fluid. Fifth one is ideal plastic fluid. Ideal plastic fluid. So we'll discuss these fluids in detail. So based on these fluids, we are having a graph also where it takes the relation, where it takes a relation based upon their properties. So what's the ideal fluid here? The ideal fluid which is a compressible, ideal fluid is which is a compressible one and is having no viscosity. So simply the ideal fluid is the one which is having no viscosity, which is having no viscosity, known as ideal fluid, which is having no viscosity, known as ideal fluid. It is only an imaginary fluid, as all fluids have some viscosity. So generally in the nature, ideal fluid అనేది ఎక్కడ ఉండదు. So generally in the nature, ideal fluid అనేది ఎక్కడ ఉండదు. But any sort of imaginary fluid, any sort of fluid which is in the nature, generally it has some viscosity, some percentage of viscosity. ఎంతో కొంత viscosity అనేది definitely ఒక liquid కానీ ఒక fluid కానీ ఉంటుంది. Right? Next, second one is real fluid. What's the meaning of real fluid? A fluid possessing a viscosity is known as real fluid. So generally, real fluid అంటే fluid లో viscosity అనేది general గా ఉంటుంది. That type of fluids we are calling them as real fluids. All fluids in actual practice are real fluids. So generally, whatever we are working on any fluid, it may be the water, it may be a kerosene, or it may be a petrol, or maybe some other engine oils. So generally, we are having some viscous nature. Okay, in the nature, whatever the fluid it is there with the viscosic nature, it is nothing but a viscous real fluid. Third one, Newtonian fluid. What the meaning of Newtonian fluid? It is also a real fluid where the stress is directly proportional to the rate of shear strain. Simply, whenever it obeys the laws, it is known as Newtonian fluid. When it does not obey the law, it is known as non-Newtonian fluid. Here, what is a Newtonian fluid? Whenever the stress is directly proportional to the rate of shear strain, it is known as Newtonian fluid. It is known as Newtonian fluid. Next, non-Newtonian fluid. A real fluid, it's also a real fluid where the shear stresses is not proportional to the rate of shear strain, is known as non-Newtonian fluid. Is known as non-Newtonian fluid. Is known as non-Newtonian fluid. Next, ideal plastic fluid. Fifth one is ideal plastic fluid. So a fluid in which the shear stress is more than the yield. Whenever the shear stress is more than the whatever we got yield value, and shear stress is proportional to the rate of shear strain, is known as ideal plastic fluid. Is known as ideal plastic fluid. So here, if you see the graph between the shear stress, and the velocity gradient du by dy, so generally already చేసిన results ప్రకారము, we take x-axis. The x-axis is a du by dy, that is velocity gradient. In the y-axis, if we take a shear stress tau, so what is the concept here? We are having fluids, ideal fluid, real fluid, and Newtonian fluid, non-Newtonian fluid. So if we take the ideal plastic fluid, it gives a straight line with the increase in the velocity gradient and changes in the velocity gradient and the shear strain. So if you say the Newtonian fluid, it obeys the law. So Newtonian fluid, which obeys the Newton's laws of viscosity, is directly proportional to shear strain. What happens? It gives a straight line, which is Newtonian fluid. Next, non-Newtonian fluid. So it takes a curve, means which does not obey the laws of proportionality. Nothing but a non-Newtonian fluid. Ideal fluid generally does not occur in the nature. So ideal fluid energy does not occur in the nature, but some sort of viscosity is there. So that's why it's graphed in the x-axis and y-axis. Next, audible is okay now? Is audible to all? Okay. So if you have any problem, just chat me. Next one.
Yes, sir.
Next, we'll see the system and control. So what is a system? What is the system? What is the boundary? What is the boundary layer surroundings? We already studied in some physics or some chemistry classes, but just we repeat for the concept of fluid mechanics subject. ఎందుకంటే మనకి నెక్స్ట్ క్లాసెస్ లో ఇవన్నీ రిపీట్ అవుతాయి కాబట్టి. So what's the system here? A quantity of a matter or a region in space chosen for study. So see the figure here. So it's a system. System means an enclosed thing which is surrounded by a boundary where you have to study some concept. That's nothing but a system. A quantity of matter in a space chosen for some study, maybe any subject point of view. So then in బయట ఉన్నది ఏమంటాము, that means simply surroundings. Just mark some place is the system. దీని బయట ఉన్నది ఏమంటున్నాము, we are calling them as surroundings. In between the surroundings and system, what we place here, it's nothing but a boundary. So దీని definition point of view లో, the mass or a region outside the system is known as surrounding. So the mass or region outside the system is known as surroundings. And what is the boundary here? The real or imaginary surface that separates the system from its surroundings. For example, మీకు ఒక ఫీల్డ్ ఉంది, ఒక పొలం ఉంది. సో ఎంతవరకు పొలం ఉంది? సో దిస్ ఇస్ టోటల్ ఏరియా ఆఫ్ సెంటర్ ఏరియా, అవుట్ సైడ్ ఏరియా. సో మీరు ఎప్పుడైతే మీరు మీ పొలంకి కానీ మీ హౌస్కి కానీ ఒక బౌండరీ లేయర్ వేశారో, then we can distinguish and then we can give the definition of system, boundary and surroundings. System, boundary and surroundings. So the surrounding is outside, is the exclusive part from the system. So system ke surrounding ki separate చేసేదాన్ని ఏమంటాము, we are calling them as boundary. Then the boundary of a system that can be fixed or movable. So fixed boundary or movable boundary. For example, if you take your car going on the road, so the car is a system, surrounding is a road outside. Then boundary is the outer line of your car where you are staying inside the car. It may be moving or it may be movable. Next, the systems may consider to open system or closed system. Open systems only రెండు రకాలు ఉంటాయి. What is that? Open system and closed system. So if you see the diagram, here, so here in a closed, in a chamber, you are taking some gas. It is a 2 kg gas. It's a volumetric 2 kg gas, and this one you are placing on the top of the gas. Then you are having some fixed boundary for the gas. Whenever this brown color portion, is not available, then automatically the gas will escape out. So here, see here. So whenever the gas is moving, whenever this boundary is moving up and moving down, what happens? The gas pressure, the gas volumetric pressure is increasing. So here it's a boundary. This up to here to this one, this portion is a fixed boundary. The top portion is moving boundary where it is moving up and down. Now see here, the same thing. In a cylinder, we are having a glass, we are having a gas which is a closed system. So we are enclosing in a cylinder, in a chamber where the energy is stored in the form of gas. Right? Here the mass, there is no mass whenever it is not moving in position. So like this, the systems are of two types: closed system and open system. Open system means it is open to the nature, where it does not have surroundings, where it does not have a boundary, but to a small extent a boundary is available. That is nothing but a open loop system and closed loop system. Next, open loop system or controlled volume. Here what happens? Here a properly selected region in space. For example, it usually encloses a device that involves, mass flow such as compressor, turbine or nozzle. For example, compressor. Compressor అంటే ఏంటి? If you take an example, మీరు సైకిల్కి కానీ స్కూటర్కి కానీ గాలి పట్టుకోవాలి. సో అప్పుడు ఎక్కడికి వెళ్తారు? You are going for outside or roadside shop to fill the air. So ఎలా fill చేస్తారు? They are using with a device called compressor on the pressure regulator. So if you see the example A here, a controlled volume with real and imaginary boundaries. Real boundary is ఇది real boundary అంటే this one. The black color portion is real boundary. This this blue color portion is imaginary boundary. అంటే gas are flowing from this side, going outside. So you could going in, coming out. But these gases are touching continuously at this point. Continuously at this point, which is a real boundary. This is simple nothing but open loop system. A controlled volume based upon the pressure regulator. Next, CB. A control volume with fixed and moving boundaries as well as real and imaginary boundaries. So ఇక్కడ ఏం జరుగుతుంది ఇక్కడ boundary is fixed, boundary is movable, and also the fluid and also the moving boundary is also moving shown in the figure. If you see the blue color portion here, the here what happens, the gas is going in but not going out. It is going in the form of energy, the blue color portion outside. So here the gas is pushing the inside the piston, the cylinder is pushing the, it is moving up and down. Inside the cylinder, the piston is moving up and down with the energy transformation takes place. Now see the example, open loop system with one inlet and one exit. ఇక్కడ ఏం జరుగుతుంది, here hot water అనేది పైకి వెళ్తుంది, right? Here we are having a water heater. It is a water heater, simple water heater where you are having the contact control surface. So if water inlet and cold water is going here, some pressure regulators, it is going inside. So for getting heated, it is going outside where you are having one entry, one exit. It is a open loop system. Open loop system. Next. Next we'll see the importance of dimensions. Importance of dimensions and units. So fluid mechanics survey mundu we have to understand some dimensions and units which are very useful for the problems point of view. So next one any units are having some problems where we will see some SI units and MKS units where you have to study some dimensions related to the fluid mechanics. Now see the definitions, very important definitions here. So a dimension is a name. A dimension is a name which describes the measurable characteristics of an object. So dimension and enti, for example, in your hand you are having a cell phone. So what is the dimension of the cell phone? How to measure the cell phone? What are the units of cell phone? What are the units of some measurement? So a physical object can be measured. An object, a physical object which can be measured is definitely having some dimensions. Okay. Here, a dimension is a name which describes the measurable characteristics of an object such as length, mass, and temperature or time. Okay. So it is a measurable character. Measurable characters unnalu oka dimension. It may be a length ante area wise, length ante width, length, height, or maybe mass, density, weight, or maybe temperature, or maybe pressure. ఎప్పుడైతే ఇలాంటి units ఇలాంటి characteristics కి ఒక physical object ఉంటాయో then we are calling them as dimension. Okay, the unit is accepted standard for measuring the dimension. The dimensions used are expressed in four fundamental dimensions, namely mass, length, time, and temperature. So A dimensions, whatever the object you are taking in the nature, the dimensions are used or expressed generally in four fundamental dimensions. What are the four fundamental dimensions? We have to keep in mind the length, the mass, the time, and temperature. మీరు ఎట్లా తీసుకోండి MLTT, mass, length, time, and temperature, or TTML, time, temperature, mass, and length. You can take in any ways. Next, what is the definition of dimension? Any physical quantity that can be measured, are characterized by dimensions. Next, the magnitudes of physical object, whenever we are having some measurement, automatically measurement we are having a magnitude. Then the magnitudes assigned to the dimensions are called units. The magnitudes assigned to the dimensions are called units. Next, some basic dimensions such as length, mass, time, and temperature are selected as primary fundamental dimensions, primary fundamental dimensions. While others such as velocity, energy E, volume V are expressed in terms of primary dimensions and are called secondary dimensions or derived dimensions. Now, dimensions we are having two categories. First category is primary dimensions. Second category is secondary or derived dimensions. So, primary category in the primary category we are having length, mass, time, and temperature. MLTT. Whereas in this secondary dimensions, we are having volume, energy, and velocity. VEV. We are calling them as velocity, energy, and volume, which are expressed as secondary dimensions. Next, if you see these in metric systems or English systems, we are having some different magnitudes. So it's simple and logical system based on decimal relationship between the various units is nothing but metric SI system. A simple and logical system based on decimal relationship between the various units is nothing but a metric SI system. Then what is the English system? It has no apparent systematic numerical base, and various units in this system are related to each other rather arbitrarily. So whenever you are using English system, there is no systematic numerical base based upon the relations given. Next, ranges now see the table here. Now see the table. So unit 3, it's a dimensions, mass, length, time, and temperature. In the symbol MD, for mass, you are having capital M. For length, you are having capital L. For time, you are having capital T. For temperature, you are having degree Celsius, that is degree. When it's converted into SI units, what is the unit we are having? kg, kilogram. What is the symbol of the kilogram? With the kg. Then what is the SI units length in meter? With the small m. In for time, you are calculating them as seconds. That is SEC or S. For temperature, Kelvin, SI units. In case you are having degree centigrade, capital K or C. Now see the 7 fundamental or primary dimensions for in their SI units. So length, mass, time, temperature, also electric current, amount of light, and amount of matter. For length, you are having meter M. For mass, you are having kilograms. For time, you are having seconds. For temperature, you are having Kelvin. For electric current, you are having ampere A. For amount of light, you are having candela. We are expressing in the dimensions of amount of light in the units called candela. CD. What's the amount of matter? We are expressing it as MOND mole. Okay. Now these are the standard prefix in SI units. So generally, if you put a problem flow, depends upon the problem, you can write these numbers. But you can remember it or you can apply for some cases. For example, 10 to the power of 9 giga, 6 mega, 3 kilo. Like this, you can do for the prefix of this system. So these are some quantities. Dimensions in SI units. These are some quantities, dimensions in SI units. So what happens in the SI units? So in the SI units, we are discussing some quantities. What are these quantities? These are velocity. So the E words already made of physics law. Ekkada use chesi untaru, right? For solving the problems. Just we will refresh this one. Later we go into the derivations and problems. Then what is the velocity? Velocity is derived meters per second. That is L T inverse meters per second. L by T అన్నప్పుడు L T to the power of minus 1. L T to the power of minus 1. Next, acceleration. Acceleration ఏంటి? Rising. L T to the power of minus 2 meters per centimeter square. Derived. That is L T to the power of 2. Next, force. MLT minus 2 Newton. That is Newton's force is derived in the Newton. That is kg per meter centimeter square. So kg ante M, meter ante L, S square means T to the power of minus 2. Pressure stress, we are deriving in a Pascal. పిఏ లేదంటే న్యూటన్ పర్ మీటర్ స్క్వేర్ అంటాం. సో దీనికి ఏంటి బేస్? కేజీ పర్ మీటర్ centimeter square, that is ml minus 1 t to the power of minus t to the power of 2. Next, density is volume, kg per meter cube. Density is equals to kg per meter cube. ఇది ఎలా చేస్తున్నాం? ml to the power of minus 3, ml to the power of minus 3. Next one, specific weight. We are deriving it as Newton per meter cube, that is kg per meter per centimeter, that is ml minus 2 t to the power of minus 2. Next one, relative density. Changes in the density. Relative density is the ratio. It's only the ratio. What is the relative density means? It is the ratio of actual density to the difference in the density. Next, viscosity. Viscosity we are discussing as Newton per centimeter, Newton per meter square. We are saying it as ml to the power of minus 1, t to the power of minus 1. Next, energy. Energy ante the work what you are doing. Joules, capital J, or Newton meter. It is expressed as ml square t to the power of minus 2. ఇవన్నీ మీరు గుర్తుపెట్టుకోవాలి, dimensions of this quantities. Dimensions of this quantities. Next, power. Power we are derived power we are showing in the watts or Newton per centimeter. Here we are saying the dimension is ml square t to the power of minus t. So based upon the base of the quantities, we can write the dimensions for the quantities also, right? So these are some of the units which are used in the fluid mechanics as we are discussing in the fluids concept of view. Okay, and as generally we know what is g, small g, the acceleration due to gravity will always be taken as 9.81 meter per centimeter square. So like this we are having the fundamental unit which are used for solving the problems. Next, applications. So fluid mechanics ఎక్కడెక్కడ అప్లై చేస్తాము? So we are having number of applications. See what is this one? This one is a heart. This one is a artificial heart. Showing here is a Penn State electric total artificial heart. Fluid dynamics is used extensively in the design of artificial hearts. Fluid mechanics, fluid dynamics is quality. So in the medical concept, it's artificial heart where from this pipe the fluid is going in, going out, pumping out through some piezoelectric system. ఇక్కడ ఏం జరుగుతుంది? ద బ్లడ్ అనేది ఎంత పంప్ చేయాలి అవుట్ టు ఇన్కి ఇవన్నీ స్టడీ చేయాలంటే we have to know the fundamentals of fluid mechanics. Next one is natural flows of weather. సో జనరల్ గా మనకి టాప్ ఏరియా నుంచి బాటమ్ ఏరియా పడేటప్పుడు వాటర్ ఫ్లో అనేది ఎలా జరుగుతుంది? ఇట్స్ ఆల్సో ఫ్లూయిడ్ మెకానిక్స్ ఇన్వాల్వ్ అవుతుంది. నెక్స్ట్ వన్, if you see the power plants. In the power plants also we require water to cool this big plant. So akkada kuda fluid mechanics anedi use chestamu. Next, boats, ships. How the boats, ships buoyancy, how the boats and ships are traveling on the surface of the water. So also fluid mechanics anedi ikkada use chestamu. Next, aircraft and spacecraft. Here we are using the aerodynamic concepts. How the aircraft and spacecraft are going in the air. We are using the air and traveling towards the destination. Next, human body law. What is the BP? How the blood is passing? How the water is flowing? How the quantity is passing from one place to other place? So also all related to the fluid mechanics. Pressure and then the intensity, the flow points, pressure points. Next one, cars, the petrol, diesel, whatever the engine or whatever the cars, vehicles are using, they're also using the concept of fluid mechanics. Next, wind turbines. To generate the electricity, we are using wind turbines. At that point also, we are using the concept of the fluid mechanics. That's the piping, plumbing system. Civil engineers ki major is the plumbing system. Water ఇలా ఫ్లో అవుతుంది. ఈ జాయింట్స్ దగ్గర టర్నింగ్ తీసుకుని ఎంత ఫ్లో వెళ్తుంది, ఈ ప్రెషర్ రెగ్యులేటర్స్ ఓపెన్ చేయడం క్లోజ్ చేయడం వల్ల ఫ్లో అనేది ఎంత ఫాస్ట్ గా ఫ్లోగా జరుగుతుంది, ఇంటెన్సిటీ ఏంటి. Like industrial applications. So these are all the piping systems where we can see the concept of fluid mechanics applications. If you have any doubts, just open the chat box. మీ అటెండెన్స్ తీసుకోబడుతుంది. టోటలీ యువర్ 7 స్టూడెంట్స్ ఈరోజు అటెండ్ అయ్యారు.